Okay, so let's continue with our discussion of matter. We earlier have said that, hey, matter, let's write it here. Here's matter. Matter is anything that has mass and volume, right? And then we said, hey, we can talk about types of matter. And we said there are two broad types. We said there are mixtures and there are pure substances, right? And we said that mixtures are a blend, and in this blend, each maintains each element, each substance in the mixture maintains its properties and identity. Identity. Good. And a pure substance, we said, hey, what makes a pure substance? We said a pure substance is something that has a fixed composition. Composition, good. And we said, hey, we have two types of pure substances. We have elements and we have compounds. And we said we have two types of mixtures. We have heterogeneous mixtures and we have homogeneous mixtures, right? And homogeneous mixtures, also known as solutions, have what? They have uniform distributions. Whereas heterogeneous are non-uniform distributions. Okay? Good. So now we want to move on to another aspect of matter, and we want to focus now on the properties of matter. Okay? Properties of matter. So, what kind of question do we want to pose? Here we go. Consider the following properties of a beaker of CH3OH, which we call methanol. By the way, things that have an OH on the end of them that start off with a carbon, these things are alcohols, we say in organic terms. You'll learn about those later in the year, I hope. So, the following properties of a beaker of methanol. It is clear, it is colorless, has a volume of 25.2 milliliters, and has a density of 0.792 grams per milliliter. And the question here is, which of these properties are extensive and which of these properties are intensive? Good. So I think we need to go back and we need to talk about some properties, right? Okay, one set of properties we can have are extensive and intensive. Extensive and intensive. Extensive and intensive properties. Okay, so what is an extensive property? An extensive property is a property that depends on the amount of matter. It only depends on the amount of matter. So these are things like weight or mass, weight, mass, volume, believe it or not, the amount of heat content. These all depend on the amount of the matter, the amount of subject that I have, substance that I have. Intensive properties, on the other hand, these guys depend on not the amount, but they depend on the type of matter. So things like color, density, appearance, shininess. Oh boy, shininess. No, that's not the way it's spelled, shininess. I can't spell shininess. Whether it's shiny or not. Those things are all related to the type. Hardness. If it relates to the type of matter, then it's intensive. If it relates to the amount of matter, then it is extensive. So let us go to our question here. Which of these properties are extensive? Remember, this relates to amount, and which are intensive, which relates to type. So, question number one, it is clear. Okay, if I have a little beaker of methanol or I have 10 gallons of methanol, will it still be clear? Well, the answer is it will still be clear regardless of the amount. So if it's clear regardless of the amount, that means it relates to the type of matter. It relates to the nature of methanol. So being clear is intensive. Colorless. Once again, if I have 5 milliliters or 5,000 milliliters of methanol, will its color change? And the answer is no. The color will stay the same regardless of how much. So that means it's not related to the amount, it's related to the type. So that means colorless is also an intensive property. Volume. Okay, here we go. Volume. Hey, if I have more methanol, will I have a greater volume? The answer is yes, absolutely. So that means volume is an extensive property. And then density. Density, 0.792 grams per milliliter. Density is something that is related to the type of matter. That means all methanol at the same temperature has the same density. Water would have a different density. So that relates to the type of matter, which means that density is over here as an intensive property. Okay? Questions on that? I hope not. If so, you'll have to see me or email me. Good. So here's a question for you all. Consider the following properties of a piece of potassium. It is shiny, it is ductile, it has a mass of 3.75 grams, it reacts readily with oxygen. Which of these properties are extensive and which are intensive? I'll give you, let's say 30 seconds to figure this one out. Okay, you think you have the answer here? Let's give it a shot. Remember, extensive properties relate to amount. Intensive properties relate to type. Good. Shiny. Does the shininess of potassium change with the amount? The answer is no. A little 5 grams of potassium has the same shininess as 1,000 grams. So that would mean that shininess is an intensive property. Shiny. Good. Ductility. What does ductility mean? That means the ability to be pulled or drawn into a wire. Now, do you think the ability to be drawn into a wire is an intensive property related to the type of matter or an extensive property related to the amount? If I have a little bit of potassium, can I draw it into a wire? If I have a lot of potassium, can I draw it into the wire? The answer is it doesn't depend on the amount. So that means that ductility, being ductile, is an intensive property. Mass. Mass of 3.75 grams. If I have more potassium, will my mass increase? Yes, it will. If my mass changes with amount, that means it is an extensive property. And finally, potassium reacts readily with oxygen. The ability to react, does that depend upon amount, or is it just related to the very nature of what potassium is? A little potassium will react, a lot of potassium will react. The answer is it's related to the type, and so that means that the ability to react with oxygen is an intensive property. Good? Okay. I hope you have no questions. Moving on. Next, we have a 28.02 grams of a gas, occupies 22.4 liters. What is its density? Okay. We want to talk about one intensive property here in a little more detail, and that is the density here. So let us take a few moments and talk about density because it's especially important to us. So here we have our density, and what is density? Density is really mass of a substance divided by the volume. Okay, so density equals mass divided by volume. Mass is usually in grams. Sometimes it's in kilograms. Volume is usually in milliliters. Sometimes it's in centimeters cubed, or sometimes it's in liters. Um, but that's the typical units for density. One thing about density is dependent. It depends on temp. As your temperature changes, your density is going to change. Good. So let us rewrite these. Density is equal to mass over volume. Now we can mess around with our algebra here, and we can say what? Volume then is equal to mass divided by density, or we could say mass then is equal to what? Volume times density. So those are the three equations we use. Density equals mass divided by volume. Volume equals mass divided by density. Mass equals volume times density. Good. So what was the question here? I have 28.02 grams. So we have 28.02 grams. This is mass, right? And it occupies liters. That means it is what? Volume. So density equals mass divided by volume. What did we say the volume was? The volume was 22.4. 22.4 liters. But, oh my, we got a bit of a problem here. Let's see. They want the density in grams per milliliter. Okay, so let's see what we have here. I have, get out my calculator, 28.02 divided by 22.4. And what do I get? I get 1.2508 grams per liter. Okay, now first of all, we have to look at sig figs. Here I have 3 sig figs, here I have 4. That means I can only have 3 sig figs as my answer when we're finally done. And notice, they want grams per milliliter. We have grams per liter, so we have to do a conversion. So what is the conversion? Well, I know that I have 1 liter over 1,000 milliliters. Okay, good. So I take my 1.2508 and divide that by 1,000. And when I divide, what am I really doing? I'm just moving my decimal place, when I divide by tens, moving my decimal place to the left 3 positions. So that would equal 0.00125 grams per milliliter. Notice my liters cancel, and I'm left with grams per milliliter. So writing this in scientific notation, 1.25 times 10 to the what? 1, 2, 3, 10 to the negative third grams per milliliter. Yikes! There we go. That is the beautiful answer to our question. Good. So let's see what the next one is. Consider a 12.07 milliliters of a substance with a density of 3.154 grams per milliliter. What is the mass of the substance? Okay, I'll give you a few minutes to work on this. Well, maybe not a few minutes, maybe 30 seconds. Okay, go. Okay, well, notice what they give us here. What does ml stand for? That stands for milliliters. So that means they give me volume, and they also give me density. So I have density and volume. So what do we know? Density is equal to mass divided by volume. So they're giving me density, they give me volume. So what is mass equal to? Mass is equal to density times volume. Good. So my mass is equal to my density, 3.154 grams per milliliter, times my volume. What's my volume? 12.07 milliliters. And when I get my handy dandy calculator out, 3.154 times 12.07. It looks to me like I get 38.068. Now, how many sig figs here? I have 1, 2, 3, 4. I have 1, 2, 3, 4. So how many can I have in my answer? I can only have 4 sig figs in my answer, so that means I have to round this 8. And I'd have 38.07 grams. My milliliters cancel, and that is it. I have 38.07 grams is the mass of the substance. Good. Okay, wonderful. Questions about density? I hope not, but if so, let me know. Next, the following properties of sodium. Consider the following properties of sodium. It is shiny, soft, and reacts readily with water. Which of these are physical properties, and which of these are chemical properties? Okay, we need to go back to our beautiful concept map here, and we need to add a couple more properties. So let's extend the page, and let's come off of properties this way. We'll go, and we'll split this into two. We need to extend the page a little more, and we'll come over here and say we've got some chemical properties, and we have some physical properties. Okay, so what's the difference between a chemical property and a physical property? Okay, first of all, in a physical property, this is a property which can be observed without changing, not changing, let's change that. It's better if we say without transforming the substance into a new substance. Okay, so a property which can be observed without transforming the substance into a new substance is a physical property. And those things are, hey, shininess, color, size, mass, those things are physical properties. Chemical properties are properties which relate to the substances, apostrophe to the substances, ability to transform. That's a T. Let's erase that and get that proper. To transform, ability to transform into a new substance. And these things usually have to do with its ability to react, combust, corrode. When you say, hey, it will corrode in water, that means that it is transforming into a new substance. And so that would be a chemical property. Good. So let's go to our question here. the following properties of sodium. It is shiny, soft, and reacts readily with water. Now, can I observe shininess without changing it? Yes. So that means shiny is a physical property. Can I test its softness without changing it? Yes, I can. So that means softness is a physical property. And finally, it reacts with water. Can I react it with water and still not transform it? No, when it reacts with water, it now transforms into a new substance, which means that the ability to react with water is a chemical property. Okay. All right, good. Well, I think that's enough for today. And next time we will discuss the changes to matter, and we're getting close to the end of this unit. Okay, have a good one. Bye.